2.6 nonlinear inequalities. To solve polynomial inequalities, 1, you need to find the zeros. 2, you need to create a sign chart to determine the solutions. Okay. Example 1. X squared plus 5x plus 6 is less than 20. So one of the golden rules is I need to move everything over to one side in order to factor. So I'm going to have to move this 20 over to the left. That gives me x squared plus 5x minus 14 less than 0. So I'm going to factor this into x plus 7, x minus 2. And basically what you're going to do now is after you factor it, you're going to determine the critical points. And so, we're going to determine critical points. You can't just simply say my x is -7, my x is 2. It's going to be basically a range. So x plus 7 is going to give me -7 as a critical point and 2. So we're going to create a number line, -7, 6, 5, 4, 3, 2, 1, 0, 1, 2. These are our critical points. And we're going to test each section. We're going to test this section over here. We're going to test the one in between. We're going to test the one on the right. So we're going to do that on the next screen. Okay, let me draw that number line again. So we're at -7, 6, 5, 4, 3, 2, 1, 0, 2. So these are my critical points. And my equation was x plus 7, x minus 2 less than 0. So we're going to test a number in each section. So we're going to test a number over here. So say, for example, in this area, I'm going to test a -10. And see 6, 5, 7, 8, 9, 10. I'm going to test -10 and see if this area is in part of my domain. And so if I test -7, or sorry, test -10, that gives me -3 times -12, and 36 is not less than 0, so I cannot include this. And since my original equation is less than, you're not going to include these. So these actually are open circles. Okay. Then we're going to go on to, and the way you can check that is I'm going to check -7. If I plug in -7, that gives me 0 times -9, and 0 is not less than 0. So these are going to be open circles. I plotted them as points originally, but if it's less than or greater than, put open circles there. If it's less than or equal to, greater than or equal to, put solid dots there. So they should be open circles. Next, we're going to test something in this area. The easiest thing to test would be 0. So 0 plus 7 is 7. 0 minus 2 is -2. And -14 is less than 0. So everything in between -7 and 0 will work if we test it. Next, we're going to test something in this area. So maybe we'll test 10. I'll do a positive 10. 10's an easy number to do. So, 10 plus 7 is 17. 10 minus 2 is 8, less than 0. And obviously that is a positive number that is not less than 0, so this is not in my domain. So my answer, my solution, basically is from -7 to -2, not including. So when you're giving solutions for inequalities, you're basically going to give me domains. So it's from -7 to -2. Next one, x squared plus 2x plus 3 less than or equal to 0. And there is nothing that's going to multiply to be 3, to be a positive 3, and add to be a positive 2. So you're going to have to do quadratic formula on this. So I'm going to do quadratic formula on this because they might be radicals. So my A is 1, my B is 2, my C is 3. So I'm going to do negative b plus or minus square root to try to find my critical points because they might be radicals. B squared minus 4ac over 2a, which gives me negative 2 plus or minus square root of 4 minus 12 over 2. That gives me negative 2 plus or minus square root of negative 8 over 2. And you'll start to notice that you're getting an imaginary. So negative 2 plus or minus 2i root 2 over 2. And when you do that, you get imaginaries. And imaginaries basically mean that they are not going through the x-axis. So this has no solution if you get imaginaries. So there are no numbers that are going to make this less than 0. Example 3. X squared plus 12x plus 36 is greater than 0. Again, we're going to do the same thing. Factor it if we can. If not, do quadratic formula. But this factors to x plus 6, which means that your critical point in this case is going to be negative 6. And since this is the same thing, you only have one of them. So at negative 6. And since this is greater than, it's not going to include negative 6. And then we're going to test numbers to the left and numbers to the right. So again, I'm going to try negative 10, positive 10. So over here, if I try negative 10, negative 10 plus 6, negative 10 plus 6, greater than 0. That gives me negative 4, negative 4. 16 is greater than 0, so this whole area is okay. Then I'm going to try on the right, this area in here. I'm going to try 10. 10 plus 6, 10 plus 6, greater than 0. That's 16. 16. Obviously, that is greater than 0. This one will work. So you basically have an answer everywhere you go except for negative 6. And if I check, if I plug in negative 6, you have 0 times 0 greater than 0. And 0 is not greater than 0. If it was, it would be solid. So your solution to this is you're doing everything except for the negative 6. So I'm going to go from negative infinity to negative 6, skip over it, and go from negative 6 out to infinity. Every number except for negative 6 will be a solution to this inequality. Example 4. 4 over x minus 6 plus 2 over x plus 1 greater than 0. Okay, so before I solve, I'm going to get common denominators. So my common denominator is going to be x minus 6, x plus 1. X minus 6, x plus 1. So that was a 4 and a 2. So now I need an x plus 1 in my numerator on the left, x minus 6 in my numerator on the right. And when I combine them into 1, that's going to distribute. It's going to give me 4x plus 4. 2 times x, 2 times 6, so 2x minus 12, greater than 0. So then I'm going to combine my like terms, my 4x and my 2x, and my 4 and my negative 12. So these two combine, that's 6x. These two combine, that is negative 8 over x minus 6, x plus 1, greater than or equal to 0. So now at least if I've got it in 1, again, for my critical points, I'm going to worry about my numerator, and then I will check my denominator later. Okay, from the last screen, we got 6x minus 8 over x minus 6, x plus 1, greater than, oops, not 11, 1, greater than 0. So since you have a rational, you also need to check. So since you have a rational, to also take into consideration that x can't be 6, x can't be 1. And then we're also going to check your 6x minus 8 is greater than 0. So 6x is greater than 8, x is greater than 8/6, x is greater than 4/3. So our critical points that we're going to test negative, 6x plus 1 from the previous screen, so this will be a -1. My critical points are going to be -1, 4/3, and 6. Those are going to be the critical places that I'm going to check. So let me add another screen to this, and then we're going to check them all. Okay, so our critical points from the last screen are -1, 4/3, and 6. So I'm just going to do -1, 4/3, 6. Okay, and I'm going to try every area in here. So in here, let's try -2. So if I try a -2 and I'm going to try this into 6x minus 8 over x minus 6, x plus 1, and that's greater than 0. Okay, so if I try -2, I'm going to get a negative number on top. So that's -12 minus 8, that's -20 over -8 and -1. So I'm going to get -20 or +8, which gives me a negative number, and a negative number is not greater than 0. So to the left of -1 does not work. In between -1 and 4/3, I'm going to try 0. If I plug in 0, I'm going to get -8 over -6 times, let me rewrite this. This should be x plus 1. It's easier to read. Back to this. 0, 1. That's -8 over -6. That's a positive number, which is bigger than 0. So this one is good. Then between 4/3 and 6, let's try maybe 2. So if I plug in 2, 12 minus 8 is 4. 2 minus 6 is -4. All I'm doing, in case you're wondering, is I'm taking this 2 and I'm plugging it in here, in here, and in here. And I'm checking to see what I'm getting. Same thing over here. Plug in 0 in here and you get -8. Plug in 0 here, 0 here. Just in case you were wondering what I was doing. If I plug in 2, 2 plus 1 gives me 3. So that's 4 over -12. That's a negative number. A negative number is not greater than 0. So I'm not going to include this area. And let me find a fourth color. And in the last section, in here, let's try 10. So 60 minus 8 would be 52. 10 minus 6 is 4. 10 plus 1 is 11. And that will be a positive number, and that's greater than, so it's going to be included. And since this was a greater than or equal to at -1, let's do this in white. Remember, the reason the -1 is here and the 6 are here is because they were undefined at -1 and at 6. And then at 4/3, if I were to plug in 4/3, you're going to get 0 is greater than 0, so you can't include the 4/3. So my only solution to this is going to be my -1 to 4/3. Let's do it over here. So -1 to 4/3 and my 6 to infinity. Those are going to be my solutions. So numbers within those domains will satisfy that equation. And since it's greater than and not greater than or equal to, these should all be parentheses.